Hello and welcome back to Data Analysis and Visualization. I'm Chivita Christie, and in this video, I'm going to show you how you can calculate which observations are outliers and which observations are not outliers by using the 1.5 interquartile range, which is IQR criterion. And I'm also going to talk about box plots, which can be drawn using the IQR. And then we are going to see standard deviation, which is a measure of spread. In my previous video, I already explained to you range and interquartile range as measures of spread. And now we are going to see another measure of spread, which is standard deviation. But first, let's begin with calculating outliers using the interquartile range. So in one of my previous videos, I showed you how to create histograms, and while we created a histogram, we created one that looked like this. This is the histogram for ages of the best actresses who won an Oscar award from 1970 to 2013. It's the same data set. And if you want to use this data set, if you want to take a look at it, it is given in the description box. You can see it. It's an Excel file. So this histogram has been created from the ages of those actresses, and those ages are given here on the x-axis, and you can see these are different actresses, and the histogram shows what was the age of an actress, how many actresses are there which were aged a certain age. So that is how this histogram has been created, and you can see that there is some sort of disconnection in this histogram where you see this value and you see the other blue area that is away from the cluster of blue areas that we can see in the histogram. And at that time we noted that this must be, these values right here must be outliers. But we do not have any fixed way of finding that out. At that time, we did not have it because we only knew a histogram. But now we know IQR, and using IQR, we can actually say for sure if these values are outliers or not, and whether we want them in our data set. Sometimes outliers need to be removed in order to make more sense from the data. So that's why it's important to know if certain values are outliers or not. And that's what we are going to find out now using the IQR. So what we are going to do is we're going to use the 1.5 IQR criterion that I talked about in the previous video and find out whether these are outliers or not, whether the 5 observations we saw on the histogram are outliers or not. So first of all, we are going to use the Q1, Q3, and IQR we found earlier in the previous video, and I'll just show it here. It is Q1 is 30.5, Q3 is 42.5, and then based on that we can calculate the IQR to be 11.5 because IQR is Q3 minus Q1. Now we are going to find out the value that we get after we subtract 1.5 times IQR from Q1. Upon doing that, what you will get is 13.25 because we multiplied 1.5 with 11.5 and then subtracted the value from 30.5, which gives us 13.25. And then we are going to add 1.5 to Q3. So now we are doing Q3 plus 1.5 IQR, which gives you 42.5, in which we are going to add 1.5 times 11.5. And once we do that, we will get 59.25. You can see it's just that the 9 has gone down, but it is 59.25. So we got two values, 13.25 and 59.25. So what we mean to say is anything that lies between these two values is not an outlier, but anything that lies beyond that is an outlier. So Let me show that to you. Now from the histogram, we found out that those values right there, which were not belonging to the group, which were not close to everything else in the histogram, could be outliers. But in this case, we are going to see the outliers based on this range that we found. Now the values that we supposed were outliers were 61, 61, 62, 74, and 80. So all 5 values are going to be outliers because they are all greater than 59.25, which is the upper limit of our range or area where we said are all the values that are necessary and they are not outliers. Now note that the smallest observation in our data is 21 because we found the minimum value earlier. So 21 is the minimum value, and we know that nothing is going to be there less than that since it's the minimum. And so we do not have any outliers that are there in that area, which is lower than 13.25. So we have 5 outliers, but all of them are greater than 59.25, and that is why they are outliers. So this is how you can know for sure if an observation is going to be an outlier or not. Now let us see how you can create box plots. So box plots are a type of a graph where you can show the interquartile range and the different types of quartiles of a data set in the form of a picture. So it is based on the 5 number summary, which is very easy for you to understand now that you know all these things. So the 5 number summary contains the minimum value, the maximum value, which we know, min and max. It also contains the median, that is capital M, and it contains the 2 quartiles that we found out while calculating IQR. So those 2 quartiles are Q1 and Q3. Q1 is the midpoint of the 50% data that is below the median or less than the median, and Q3 is the midpoint of the 50% data that is above the median or higher than the median. So these values, that is min, max, Q1, Q3, and capital M, together form what we call the 5 number summary of a data set. And this summary can be used in order to create a box plot. The box plot can be created in this manner. We are going to use this data which we have for Best Actresses data set. These are the actresses who won the Best Actress Award in the Oscars from 1970 to 2013. And we are going to create whiskers on our box plot using this data. So we calculated that Q3 is 42, Q1 is 30.5. The interquartile range IQR is 42 minus 30.5, which came up to 11.5. And then we are going to also use the 1.5 criterion to show what outliers are present. So using that 1.5 criterion, we have the value 17.25 and we have the value 59.26, which are the 2 values for our 1.5 criterion. Now let's take a look at what the box plot looks like. So this is what the box plot will look like. You can see here that right in the middle, we are showing M, which is the median. And that median you can see on the axis over there, y-axis, where we have the values. So based on that value, we are going to plot the median. Once we have plotted the median, we are going to plot Q1 and Q3 right above and below the median. And once we've done that, that means our box is ready. Now we are going to, whatever is there in the box is actually our interquartile range. So everything else will fall outside the box. So to create the line above the box, we are going to use, to create the line above the box, we are going to use the 1.5 criterion, which you can see That is the line going above 1.5 criterion. Below the box, we are using the min because we saw earlier that the minimum value 21, it falls within this 1.5 area, and that's why, and plus we do not have anything less than the minimum value. So we do not have to show min separately. We're going to show it with the box itself. And the maximum value you can see is right on top. The reason for that is we have observations that are falling way beyond this 1.5 criterion, which are outliers. And that's why our max is going up there. It is not part of the box plot. So the range is everything from minimum to maximum. That is how much our data spreads. But using the box plot, we can show that this is exactly the data which does not contain any outliers. So that is how you can create a box plot. And box plots are very helpful when you have multiple data sets and you want to compare them. Then you just need to create multiple box plots. And because they are so small for each data set, we can create multiple of them side by side, and we can compare one data set with another by looking at their box plots. Now let's talk about the measure of spread called standard deviation. So standard deviation is another measure of spread that we are going to see, which is the third measure of spread that I'm going to talk about after range and interquartile range. To calculate standard deviation, we are going to use this data of number of customers who entered a video store on in 8 consecutive hours. So let's say that there's a time from 12 p.m. to 8 p.m. and every hour we are keeping a track of how many customers entered a particular video store. And those numbers are given here. We have 7, 9, 5. We have 13, 3, 11, 15, and 9. Now using this, we are going to find the standard deviation for this data. To do that, first of all, we need to find the mean. The mean is simply the average of this data. So we are going to add everything, 7 plus 9 plus 5 plus 13 plus 3 plus 11 plus 15 and plus 9. Add everything divided by 8 because we have 8 observations, and we end up getting 9. So 9 is the average or mean of this data set. Now using this average or mean, we are going to find out deviations. So to find those deviations of the data, we are going to subtract mean from each and every observation, even if you get a negative value. So you can see when you subtract the mean from the first observation 7, we end up getting -2. Second observation gives us a 0. Third observation gives us -4. Then we have 4 and -6 and 2 and 6 and 0. So these are the different deviations that we got. Now using these deviations, we are going to find the squares. So we are going to find the squares of those deviations that we found earlier. When you find squares, then the negative sign before the number does not matter because it's going to turn positive since we are taking a square. So these are the squares we get: 4, 0, 16, 16, 36, 4, 36, and 0. Now this will lead us to getting the variance, something called variance. So when you find that, which is the average of the squared deviations, that gives us variance. So what we have is 4 plus 0 plus 16 plus another 16, 36, 4, 36, 0. Divide that by 8, you will get 112. If you divide that by 8, you will get 14. So 14 is your variance, how much the data varies. And now we are going to see the standard deviation. Standard deviation is nothing but the square root of variance, which is square root of 14, which gives us 3.74. And it's close to 4, so we are just going to round it up and say that it is 4. So that's how you can calculate the standard deviation. Now, what exactly does a standard deviation mean? So standard deviation, when I say that it is 4, but the average is 9. So 9 is what is a measure of center. That means there were 9 people visiting on an average every hour. There were 9 people on an average who visited the video store from 12 p.m. to 8 p.m. But how many visited every hour? 9 is an average. So I can say that there were 9 plus or minus 4 people who visited in this time period. So it shows me the spread, how much further the data is spread from the center, which is 9, which is the average. From there, how much further the data is spread. Now, the standard deviation also helps us to conclude some other things about our data. And for that, we will be using the standard deviation rule. What you see here is another histogram, and you can see how perfectly shaped it is. It is completely symmetric, and it is distributed well. There is no skewness present here, and it is a perfect histogram. This type of a distribution is usually called a normal distribution because it is distributed symmetrically and evenly, and it has only one mode, so it is perfectly distributed, unimodal. And now, if you have this type of a graph or something similar to this type of a graph, then you can use the standard deviation rule, which says that approximately 68% of the observations here will fall within one standard deviation of the mean, which means your mean is 9, then 68% of your data will fall between one standard deviation, which is 9 minus 4 and plus 4. So you're just subtracting 4 ones. So 68% of data will fall there. 95% of the observations will fall within another 2 deviations of the mean. So this time you subtract 4 from 9 twice, and also add 4 to 9 twice. And the range that you get, that is 95% of your data. And then the rest of, we're talking about the 99.7% of data, which will fall between 3 standard deviations of the mean value. And you'll get to know this better with a diagram. So here you can see the diagram. And within the diagram, you will notice how the mean and standard deviation calculation is done. So right in the middle, you have the mean. And then on the left side, you have mean minus standard deviation. On the right, there is mean plus standard deviation. The area between that is 68% of your data. We can widen this range by now adding twice the standard deviation and subtracting twice the standard deviation from mean. And then the range that we get is actually 95% of your data. And finally, what you see right in the bottom is the 99.7% data, which is found by adding and subtracting 3 times the standard deviation from mean. So that is what your standard deviation rule is, and that is how it is applied on a normal distribution. So that's it for this video. I'll see you in the next one. Thank you for watching.